Hi, I'm Shelby, and I'm going to be teaching you about electron and molecular geometries. We're going to start off with those compounds that have two electron groups. So for example, carbon dioxide. This is the Lewis dot structure for carbon dioxide, and it says the electron geometry is linear, the molecular geometry is linear, and the bond angles are 180 degrees. This can be explained when you look at the model. It is linear because it is in a straight line, and that's also why the bond angles are 180 degrees. You see that there are two bonding groups and no lone pairs of electrons, making it linear. Moving on to those compounds containing three electron groups, first we have boron trifluoride, or BF3. Here is the Lewis dot structure of the compound. The electron geometry is trigonal planar, and the molecular geometry is also trigonal planar. The bond angles are 120 degrees. Looking at this model, you can see that there are three bonding groups and 0 lone pairs, making it trigonal planar. The molecular geometry is also the same for this, and the angles are 120 degrees each way. We also have sulfur dioxide, or SO2. The electron geometry is trigonal planar again because there are three electron groups. However, the molecular geometry is bent, and the bond angles are less than 120 degrees, as can be seen by this model. There are two bonding groups, but since there is one lone pair, it is a bent shape, making the angles less than 120 degrees. Now I'm going to show you compounds containing 4 electron groups. The first is methane, or CH4. Here the Lewis structure is shown, and it says that the electron geometry is tetrahedral, as well as the molecular geometry, and the bond angles are 109.5 degrees. When you look at the model, you can see that there are 4 bonding groups, and there are 0 lone pairs, making the structure tetrahedral, and each angle between the bonds is 109.5 degrees. We also have ammonia, which is NH3. The electron geometry is also tetrahedral, but the molecular geometry is trigonal pyramidal, and the bond angles are less than 109.5 degrees. When you look at the structure, it is similar to that of methane, but however there is a lone pair on top. So there are still 4 electron groups, but there are 3 bonding pairs and 1 lone pair, making the shape trigonal pyramidal with the angles less than 109.5 degrees. We also have H2O, or water. The electron geometry again is tetrahedral, but the molecular geometry is bent, with the bond angles being less than 109.5 degrees. When you look at this structure, you can see that it is a bent shape because of the fact that while there are still 4 electron groups, there are only 2 bonding groups and 2 lone pairs on top, making the shape bent. Moving on to those structures with 5 electron groups, first we have phosphorus pentachloride, or PCl5. The electron geometry is trigonal bipyramidal, the molecular geometry is also trigonal bipyramidal, and the bond angles are 120 degrees equatorially and 90 degrees across the axis. When you look at this model, it shows that there are 5 electron groups, and all 5 of them are bonding, and there are no lone pairs, making it trigonal bipyramidal. These bond angles are 190 degrees, and the other ones are 120 degrees this way. We also have sulfur tetrafluoride, or SF4. The electron geometry is the same, which is trigonal bipyramidal. However, the molecular geometry is seesaw, and the bond angles are less than 120 degrees equatorial and less than 90 degrees axial. When you look at this shape, you can see that it is sort of seesaw shaped. There are 4 bonding groups, 1, 2, 3, 4, but there is 1 lone pair on the top, making it that shape. Again, these bond angles are 90 degrees, but the others are 120 degrees, going this way, or less than rather. Now we have bromine trifluoride, or BRF3. The electron geometry is trigonal bipyramidal. However, the molecular geometry is T-shaped, with bond angles being less than 90 degrees. If you look at the structure, There are 3 bonding pairs and 2 lone electrons, making it a T-shape, and each of the angles will be less than 90 degrees. Xenon difluoride, or XeF2, also has 5 electron groups. The electron geometry again is trigonal bipyramidal, but the molecular geometry is linear, with bond angles less than 180 degrees. If you look at the structure, the bonds are linear. There are 2 bonding pairs and 3 lone electrons. Each of the angles is 180 degrees because it goes in a straight line. Last but not least, we have the compounds containing 6 electron groups. First, we have sulfur hexafluoride, or SF6. The electron geometry for those compounds containing 6 electron groups is octahedral. The molecular geometry for this particular compound is also octahedral, with bond angles of 90 degrees. When you look at the structure, there are 6 bonding pairs and 0 lone electrons. Each of the angles is 90 degrees. Next, we have bromine pentafluoride, or BrF5. It is also octahedral in electron geometry. However, its molecular geometry is square pyramidal, with bond angles less than 90 degrees. If you look at this structure, there are 5 bonding pairs, but there is 1 lone electron, making it square pyramidal. Finally, we have xenon tetrafluoride, or XeF4. The electron geometry is octahedral, but the molecular geometry is square planar, with bond angles of 90 degrees. If you look at the model, there are 4 bonding pairs and 2 lone electrons. It looks like a square, and each of the angles are 90 degrees, making it square planar. In summary, those structures containing 2 electron groups will always have a linear electron geometry. Those containing 3 electron groups will always have a trigonal planar electron geometry. Those with 4 electron groups will always have a tetrahedral electron geometry. Those with 5 electron groups will always have a trigonal bipyramidal electron geometry, and those with 6 electron groups will always have an octahedral electron geometry. However, the molecular geometry for each structure will vary depending on the number of bonding pairs and lone pairs in each structure. Thanks for watching, and I hope you learned something about molecular and electron geometry.